Chapter 8 Systems of Linear Equations. Section 1 Introduction to Systems of Linear Equations. In this introductory section, we will cover what is a system of linear equations, various forms to represent a system of linear equations, and the practical importance of a system of linear equations. A system of linear equation is a collection of one or more linear equations involving the same set of variables. Each equation in a system represents a linear relationship between the variables, and the solution to the system is the set of values for the variables that satisfy all the equations simultaneously. As a general form, a linear equation in two variables, x and y, can be written in this way. Here, a, b, and c are constants, while x and y are variables. The equation represents a line in the Cartesian plane. If there are more variables such as x1, x2, xn, the equation represents a hyperplane in n-dimensional space. Let's consider this equation. This equation represents a straight line in the xy plane. It can be rewritten in slope-intercept form. Any point xy that lies on this line satisfies the equation. A system of linear equations consists of two or more linear equations with the same set of variables. The goal is to find the values of the variables that satisfy all the equations simultaneously. A general system of two linear equations in two variables, x and y, can be written in this way. Here, a1, b1, c1, a2, b2, and c2 are constants, while x and y are variables. As an example, let's consider this system of two linear equations. This system represents two lines in the xy plane. The solution to the system is the point xy, where the two lines intersect. These equations can be rewritten in slope-intercept forms. For this system, the solution is x equals 0 and y equals 2, since these values satisfy both equations. We can represent systems of linear equations in various forms, depending on the context and the desired method of solution. The three most common forms are equation form, matrix form, and augmented form. Equation form is the standard form where each equation is written explicitly with its variables and constants, as shown in the example above. Matrix form expresses the system of equations using matrices and vectors. This form is particularly useful for applying linear algebra techniques and computer algorithms. Augmented matrix form is a compact representation of a system of linear equations, where the coefficients and constants are combined into a single matrix. It is especially useful for performing row operations and solving systems using methods like Gaussian elimination. Let's see the matrix form of a system of linear equations. To represent a system of linear equations in matrix form, we use the coefficient matrix, the variable vector, and the constant vector. For this general system, the matrix form is Ax equals b. Here, A is the coefficient matrix, x is the variable vector, and b is the constant vector. Let's see an example of matrix form. Consider this system. In matrix form, this system is written in this way. An augmented matrix is a matrix that includes the coefficients and constants of a system of linear equations in a single matrix, separated by a vertical line. The augmented matrix provides a compact way to perform row operations and solve the system. For this general system, the augmented matrix can be written in this way. Let's see an example of augmented matrix form. Consider this system. In augmented matrix form, this system is written in this way. This matrix includes both the coefficients and constants of the equations, allowing for a compact representation. Systems of linear equations are important because solving them enables us to find the exact values of variables that satisfy multiple constraints. This ability provides a framework for modeling and solving real-world problems. They are used in various fields to describe relationships between variables, optimize functions, and make predictions. For example, systems of linear equations are used in regression analysis, where the goal is to find the best fitting line or hyperplane that minimizes the error between predicted and actual values. Linear regression models can be formulated as systems of linear equations, and solving these systems provides the optimal coefficients for the model. Let's wrap up. A system of linear equations is a fundamental mathematical tools that provide a framework for modeling and solving real-world problems. It is a collection of one or more linear equations involving the same set of variables. Each equation in the system represents a linear relationship between the variables. The solution to the system is the set of values for the variables that satisfy all the equations simultaneously. By representing systems of linear equations in different forms, such as equation form, matrix form, and augmented matrix form, we can apply various methods to find solutions and optimize processes. In the following sections, we will explore the methods for solving systems of linear equations in more detail, focusing on Gaussian elimination and other techniques. Thank you for watching. Please thumbs up and subscribe to my channel.